All right, everyone, we are moving on to our final unit for this e-learning. And really, it's a very, very short unit. We're just doing 2 learning targets. The target 0 that we did the other day was just a good review of factoring, and you'll see why we are doing that review of factoring, because you're going to need to know it for some of this stuff that we're doing here. So this unit is all about rational expressions, and we're going to talk about what a rational expression is. Today we're going to simplify with rational expressions. Our next section we are going to add and subtract with rational expressions, and again we'll talk about what that means here. So in this beginning part here, this is just a little introduction. I said, given this function f and g, think about it carefully. So far, we're not going to do it right now, but so far this year we have done f plus g, we've done f minus g, and we've done f times g. What operation haven't we done? Division, right? We haven't really thought about dividing with these polynomials so far. So we're going to start off with some quick review here. This should be very easy review for us. If I gave you 4 over 8 and I'm asking you to simplify it, hopefully you think, okay, well, I can divide the numerator and denominator here by a common factor. You can divide both of them by 4, right? So I can divide that numerator by 4, I can divide the denominator by 4, and that gives us a 1 over 2. Hopefully I overcomplicated that even for you, because hopefully that is pretty simple, but that's, remember, what we're doing. That's a common factor right there. So same thing for the next one. If I gave you 12/15, again, we want to try and divide by a common factor. So in this numerator, I can divide by 3, and the denominator I can divide by 3, and that gives us 4/5. So again, hopefully very simple. That's just simplifying with fractions there. Now, if you look at number 3 and 4, these look a little weird, but I wanted to kind of talk about this here. So if I give you 4 plus 8 in the numerator and 2 plus 1 in the denominator. So reasonably speaking, okay, we know 4 plus 8 right here, if I did that numerator, is 12, and the denominator is 2 plus 1, or 3. 12 divided by 3 is just 4, and that is the correct answer right here. That does simplify to 4. Now, would you get the same thing if I were to cancel these numbers out? Okay, if I gave you this, could I cross these off and get, oops, sorry, I rewrote this down wrong here. Let me fix that. That was a 1. Could I cancel this 4 and this 2 and reduce that and make it a 2 over 1? Does that give us the same answer? That would give us 10 over 2, or 5. Not the same thing. Cannot do that. Okay, I wanted to point that out here. You cannot just cancel when you are adding or subtracting along the way there. Let's look at the next one here as just another example. So let's do it the right way. We're going to add across the numerator. 3 plus 7 gives us 10. 3 plus 2 in the denominator gives us 5. And 10 divided by 5 gives us 2. Again, that is the correct answer on this one here. Okay, that's right. Now, again, does it work to do it the other way? So I have 3 plus 7 and 3 plus 2. What I find a lot of people want to do on one like this is just cross off the 3's, and we get 7 over 2. Does that work? No. Okay, so 7 over 2. No, that doesn't work. What if I got, oh, sorry guys. Let me get it back here. All right, what if I got, reduced that to a 1 over 1, and I got 8 over 3? Is that the same thing? No. So again, the big thing I want you to look at on these is when you are adding, when there's that plus in there, and if I even had one of these as a minus, I didn't do any of them as a minus, but if I did, you could not just start canceling. That's going to be something that's really, really important when we are simplifying with these rational expressions. Again, you can only divide a common factor. Really, if I looked at number 1, now I'm not going to make you overcomplicate on one like this, I could write this as multiplication here, right? 4 times 1 and 4 times 2. If I write that in like a factored form, that common factor now can reduce. That would give us, that would give us a 1 over a 1, and that would reduce to 1/2. Here, if I rewrote 12 as 3 times 4 and rewrite 15 as 3 times 5. Again, if it has a common factor, factor means that you are multiplying. Then you can get and then you can reduce those factors within there. Okay, that's going to be super important on that. So let's look back to the f over g. If I did f over g, so function f is x squared plus 4x plus 12, and function g is x squared plus 10x plus, oh, I'm sorry, minus, no, yeah, plus 10x plus 24. I'm looking at my wrong thing here. Okay, so if I am dividing this one is a minus. That's what I'm struggling with here. That's a minus. Okay, which one does that equal? Take a second and think about it here. Okay, based off of what we just said, can I start just crossing things off? Can I reduce this 12 and the 24? Can I reduce this 4 and this 10? Hopefully you answered no, you just told me I can't, and that would be correct on that. So this one does not equal this first one right here. A lot of people are like, oh, I can cross off the x squareds and reduce everything. You cannot do that. I'm going to undo on all of these here because I don't want you to be able to think that we are able to do that. It is not going to equal this first one. So it is in fact going to equal this. So how would we get it equal to this? Again, you can only reduce it if it's common factors. So if you remember, our whole last homework was all about practicing factoring. I can factor that numerator, x plus 6 and x minus 2. I can factor the denominator to an x plus 4 and an x plus 6. Now, do we have a common factor, things that are multiplied together? These are common factors. Those can cancel. And that is how I get my simplified answer. That's going to be the basis of what we're doing. I'm going to get to a lot more examples on that in just a minute, but that's just kind of something I wanted you to recognize from this top part here. Okay. Now, before we get to everything, let's talk about first what is a rational expression. Basically, what we were just doing is a rational expression. It's an expression that can be written as a ratio of two polynomials. That's the key thing. Basically, it is a fraction. A fraction is a rational expression. Here's another key part though. It says where the denominator is not 0. That's going to be really important on these because when we think about dividing, remember one of our big rules is we cannot divide by 0. So just a couple examples of what a rational expression is. What we just did up here, x squared plus 4x minus 12 over x squared plus 10x plus 24. That is an example of a rational expression. It doesn't have to be trinomials. It can be a monomial over a monomial, binomial, trinomial, anything. I could do a binomial down here. Again, really, it is just a fraction. So we're going to think about that idea of where the denominator is not equal to 0. So this is what creates what we call an excluded value. An excluded value is a number that makes the rational expression undefined. This is going to be really, really important later on when you get to Algebra 2 and pre-calculus and calculus and so forth, when you start thinking about what is making that denominator equal to 0. Once you start graphing these, you're going to see what those numbers do to the graph. And again, I'm not going to get into all of that right now, but that's something that's going to be coming in later. So we're going to look at excluded values, numbers that make the rational expression undefined. So I'm going to write in here that we can't divide by 0. Divide by 0. That's super important on there. So what we want to do is we want to find what makes the denominator equal to 0. And what that's going to do is tell me my excluded values. Okay, so let's just do that here. So state the excluded values for the rational expression. You're going to have to do more than just this in the homework. It's just a little preview of it here, though. So we want to know what would make that denominator equal to 0. So what values for x would make that 0? That's an excluded value. So what I'm going to say is I'm going to say x cannot equal this number, because if x were equal to this value, that denominator would be 0. This one I hope you can look at and go, well, I know 6 minus 6 is 0, so x cannot equal 6. That's our excluded value. This one you might have a harder time coming up with in your head. So again, what we want to think is this denominator cannot equal 0. So if we were to solve it just like a normal, basically equation, except this has a does not equal 2 here, we would get that x cannot equal negative 3 halves. This should look kind of familiar when we did factored form when we were graphing. That gave us the zeros. Kind of the same idea, at least in the solving part of it, but here we are looking specifically at the denominator. Notice the numerator didn't really matter in my excluded values because the numerator can be 0. You can do 0 divided by anything, but that denominator can never equal 0. So that's really the main one that we're looking at. Now, if I look at this one here, 9x squared minus 18. All right, given this, there's not much we can do on this here. So if I'm looking here, and this was, you know what, this was supposed to be an 18x on there. I'm going to fix that in ours. So that should have been an 18x. So if I look at this, there is a greatest common factor of a 9x, and that leaves us with an x and a minus 2. Okay, so when we look at this here, we do not want any of that equal to 0. So think about how we solved quadratics in a couple units ago. So that means we are saying 9x can't be 0 and x minus 2 can't be 0 is what we're really thinking about on there. Oops, that should have a 0 there. So x cannot equal 0 and x cannot equal positive 2. All right, finally, last one. Again, to solve this quadratic equation, again, we want that denominator. We want to find out what makes it 0, so we have to factor it. So x minus 7 and x plus 2. I'm going a little quicker through the factoring. So let's just do this one in our head. That tells us that x cannot be 7 and x cannot be negative 2. You can just write it like this with a comma in between it there. Okay? All right, let's try a couple of these all together here. So you'll notice the directions, and these are the directions on the homework. First, we want to simplify, and then we want to name the excluded value. So I'm looking for both parts of it here. So to simplify, we cannot just start crossing things off. It's very, very tempting to want to do that. You cannot do that. If I see that on your homework that you're just crossing it off without factoring, you're not going to get points for that assignment. Okay, that's really important because that's a big, big part of this here. We can only cancel if it's common factors. So that means we are going to have to factor. So nothing I can do with that denominator. That denominator is already a factor on its own. There is no GCF. But the numerator, I'm going to go a little quicker through our factoring. So multiply to 5, and in this case add, to 15, in this case add to 8. So we have an x plus 5 and an x plus 3. We want to see what can cancel. We have a common factor of an x plus 3. Again, what's happening, we're not just really crossing them off. What we're saying is x plus 3 divided by x plus 3 would be 1, right? So those would reduce to a 1. So if I simplify, that means this actually ends up equaling x plus 5. However, okay, when I go back and think about my original problem right here, I'm thinking of my excluded values. Now, in my answer, I don't have any denominator. So you might think, okay, well, there are no excluded values. But what we always actually have to do is think about the original problem. What number for x would make that denominator equal to 0? So in this case, negative 3 would make that. And so that is an excluded value. We actually are going back to that original problem, or the original problem that's in factored form. And we'll talk about that here in a minute. Okay, let's try another one here. So we factor. The numerator has a GCF of 4a squared, and I'm left with a minus 3. My denominator can factor as an a and an a. We want numbers that multiply to negative 6 but add to negative 1, so a minus 3 and a plus 2 right there. So now again we look and see what can cancel here. So a minus 3, those can reduce right here. So that leaves me with a 4a squared in the numerator and an a plus 2 in the denominator. Now, can I reduce the 4 and the 2? I hope you answered no, because This is the sum right here. If it were a times 2 in the denominator, then you could reduce it. But because it's an a plus 2, you cannot simplify any more. So let's look at excluded values. So a cannot equal. Again, we need to think back to the original problem before we even canceled stuff out. I'm going to look back to the original factored version, because looking back at the original up here, you can't necessarily tell what's going to make that equal to 0 in the denominator. So I'm going to look at the factored form. So that means a cannot equal 3 and a cannot equal negative 2. Okay, let's try some more here. So we're going to factor. So here, h plus 5 and h minus 4 for our numerator. In our denominator, and hopefully I don't go too fast here, we get h plus 5 and h plus 6. So let's see what can reduce. We've got an h plus 5, so that gives us an h minus 4 over an h plus 6. So on this one, can I reduce the 4 and the 6? I hope you answered no again. Again, whenever there's a plus or minus, when it's a sum or difference, you cannot reduce anymore. It is only when it's multiplying. I'm going to keep asking that because I'm going to keep trying to drill that into your head there. So again, we look back to the original factored form to find our excluded values. So h cannot be negative 5 or negative 6. That would have made the original problem that denominator equal to 0, and we cannot divide by 0. All right, let's keep going. This is some good practice at factoring. Nothing I can do to factor that numerator, but my denominator is a trinomial, and it's a trinomial with a leading coefficient of 2, so I know it's going to be a 2x and an x. So we need numbers that multiply to 5. I'm going to do a 5 and a 1. If I make this 5 positive and the 1 negative, the first and last would give me 10x, and that middle terms would give me a minus 1x. That gives us the 9 that I want. So we can reduce x plus 5 divided by x plus 5. Those would equal 1 when we divide those. So those would cancel out. Now, this is what I end up seeing a lot of people write. However, I'm going to say this is wrong. Can you think about why? Hopefully you noticed that 2x minus 1 was in the denominator, so it has to stay in the denominator. So what is going to go in the numerator? Can I just leave my numerator blank? Hopefully you're like, no, I can't just leave it blank. But again, think about what's actually happening. X plus 5 divided by x plus 5 is 1. That means we have a 1 in that numerator. So again, we're looking at our excluded values back to the original factored form. So I'm going to do this in my head. We would add the 1 and divide by 2. X cannot equal 1/2 or negative 5. Okay, few more here. GCF in this numerator is a 10x. That leaves us with an x and a minus 2. The denominator here has a GCF of 5x cubed, and I'm left with a 3x and a plus 1. Okay, so you might be looking at this one going, well, wait a minute, the stuff in parentheses doesn't cancel. That's okay. Sometimes it doesn't cancel. That just means, all right, I still have an x minus 2 in the numerator and a 3x plus 1 in the denominator. Nothing reduced there, no big deal. But these don't have any pluses or minuses. These are just monomial terms. This actually goes back, if you remember, when we did our exponents unit way in the beginning of the year. These are monomial terms right here. So because they really are factors, everything here is being multiplied, you can reduce it. So 10 divided by 5 gives us a 2. And then we have an x in the numerator, but 3 x's in the denominator. That means our denominator is going to have 2 of them. So I'm going to rewrite this 2 just a little bit closer here. And this is all that reduces, and that's our final simplified answer. So when we look at what x cannot equal, again, I go back up here. Now right here, I have a 5x cubed. Think about that as one factor basically on its own. I mean, it's technically a few more factors than that being multiplied. But if you think about it, x could not equal 0 from that one. And then from the other term, it would be a minus 1 and divided by 3. X cannot equal negative 1/3. All right, few more to look at here. This numerator, it factors right here. We have an x minus 8 and an x plus 4. Then our denominator is a difference of two perfect squares, so x plus 4 and x minus 4. So when we look at what can reduce, x plus 4 divided by x plus 4 is 1. I get x minus 8 over x minus 4. Can I divide this negative 8 and negative 4? Again, hopefully you said no. Stop asking me that because, again, you cannot do it when it's a sum or a difference. So x cannot equal from here a negative 4 and a positive 4. If you wrote plus or minus 4, that would be good there as well. All right, hopefully you're getting the idea of these. I'm going to do a few more. I'm going to again kind of go a little bit quicker through the factoring here. But once you get the hang of these, again, you'll really notice that it's just all about how you factor it. So it's super important to make sure you keep track of your factoring and know what you're doing with those. So right here, I factor numerator and denominator. The x plus 1's cancel, and I get a 6x over an x plus 4 here. Again, excluded values, x cannot be negative 4 or negative 1. All right, looking at this one, is there anything I can do to factor that numerator 3x plus 4? Nope, no GCF, no x squareds or anything, so nothing I could do there. So in this denominator, I'm going to factor it as x plus 4 and x minus 1 here. All right, what can reduce? Can I cancel the x plus 4's right here? Hopefully you're like, no, because this is a 3x plus 4. So can anything reduce on this one? No. Now, is that going to happen a lot if I'm asking you to reduce on these? No. But this is just the factored form. Nothing can reduce. That already was in simplified form. And that's okay. Sometimes things don't have any common factors in the numerator and denominator. So we can still have excluded values, though. X cannot equal negative 4 and x cannot equal 1. All right, last one. GCF in the numerator is a 3x. I'm left with an x plus 2. And then in that denominator, we have a GCF of a 6x cubed. And I'm left with an x squared minus 4. Ooh, that denominator can cancel even further. So I'm going to rewrite that numerator, but that denominator has a difference of two perfect squares. Remember, sometimes factoring has more than one part to it. Now that it's in factored form, I can look and see what reduces here. So the x plus 2's, ooh, gone. Now look right here. Again, we have monomial terms. Those can reduce. So we've got a 3 over a 6 that reduces to a 1/2. 1x in the numerator, 3x's in the denominator here. And that leaves us with 2x's down here in the denominator. And then we also have that x minus 2 left in the denominator. What do we have left in the numerator? Just a 1. Again, when we reduce those, it's not just like crossing them off. We can cross them off because x plus 2 divided by x plus 2 is 1. X divided by x is 1. 3 divided by 6 was 1 over 2. So that 1 is in the numerator. Naming our excluded values, you'll notice that there's 3 things in that denominator. So x cannot equal 0, negative 2, or positive 2. You can have multiple excluded values. All right, try these on your own. Hopefully you're doing okay on these. Again, practice the factoring. Don't forget to simplify and name excluded values. All right, bye guys. Have a good one.